Okay, so can start.
Okay. Right, let's go to wave motion. Okay, the teacher is not too fast. He's covering okay, except that 1 week to cover wave motion is a bit too fast only lah. That's what I would comment lah. Especially unless all of you are good student, you know, A student, then okay, can go fast. But
No, like average lah, cikgu, teacher.
the main thing to ask is, do you understand what he's teaching?
Okay.
Okay lah, then
Trying
okay
to
lah.
understand. Sometimes he explain the complicated thing also can't understand.
Okay, let's go to progressive wave. 20.1, 20.2 is intensity.
Oh yeah, he finished the whole thing already. Yeah.
Then principle of superposition. Then 20.4 standing waves. 20.5 electromagnetic waves. Okay, as usual, we are on page 42 for your reference book. We start with progressive waves. That's your syllabus. You need to know the equation, interpret and use progressive wave equation, either one of them, both of them lah. Catch and interpret the displacement time graph and displacement distance graph. Then use a formula, that formula, and derive and use this equation. Okay, so basically all this formula lah, you have to know how to use it. And then if we got time, we go to wave motion. I equals to proportional to amplitude square, and then define intensity, describe the intensity, describe the variation of intensity with distance of a point source. Now we are interested in a point source as well in space. Okay, so if you find Friday not suitable, because I see you struggling to cope with Friday, then we can have Saturday 2 hours. Think about it.
No, 2 hours I'll be almost sleepy.
No, 2 hours is too long, but if you are struggling Friday, you finish your class at 12 o'clock, you should go back and take a short nap first before you come for tuition. If not, you cannot concentrate and you're struggling to keep your eye open. What's the point? Anyway, you think about that. Okay, types of waves, page 44, we got longitudinal wave. Right? Can stimulate using a slinky spring. Right? You push it to and fro. Right? There's a vibration. It produces a longitudinal wave. Or transverse wave, where your hand move up and down vertically, and the wave travel this way. Okay, that's how the energy is transported. As the wave moves along, the energy is transported to the other end. Same here, energy is transported to the other end. Right? Two types. So transverse wave, what? The displacement is perpendicular direction of propagation or travel of the wave. Example, electromagnetic waves, right? Which you will study later on. Ripple, water waves, right? Ripple in your ripple tank experiment, water waves. Right? That is your, basically it's just that transverse wave. You take off the axis there, and there's the direction of travel or direction of propagation. Then the particle vibrating or displacement is vertically. That's how the vibration is, or called vibration, or direction of displacement, up and down. There's direction of travel. So that's transverse wave. Then longitudinal wave, you can use a tuning fork. Right? You hit a tuning fork on the table, and then you will hear, if you put your ear near enough, frequency, the amplitude is very low, that's why it's very soft. Only near you can hear the sound wave there. Okay, where you have C is compression, R is rarefaction. Right? In this case, the displacement or vibration is parallel to the direction of propagation. Example, sound wave. Right? So sound wave pass the air alternately, right? Compression, you see compression, C, and rarefaction, R. Right? We'll define further. That's your tuning fork. So you can use slinky spring. Slinky spring, move it to and fro, the vibration. So if you are required to draw, that's your vibration or displacement. That's the direction of propagation. That's how you draw it. Polarized. Transverse wave can be polarized. That's how you differentiate it, whether it's transverse or longitudinal. Polarized means that the oscillation of the wave can be restricted to vibrate in one direction. Right? It can vibrate up and down, slanting, horizontal. They have different directions, but we can restrict it to one plane. That's what it means by polarized. One plane of vibration. Longitudinal cannot. That's how we differentiate the two. Right? Basically, this is just to illustrate to you. Right? That is your wave. It can be in any direction. Coming in, it's called unpolarized. So we use a polarizer or Polaroid in your sunglasses set to restrict. That's why we use Polaroid sunglasses. You cut the intensity of light to half. Right? So you basically restrict it to one direction. Like the wave can only pass through this slot only lah. But if you use a perpendicular direction, you cut out the wave completely. That's why we use two Polaroid sunglasses. You turn it around, you will see one stage there. If you look at the other side, no light at all. Right? You see darkness. So that's what's happening now. That's your polarizer or Polaroid. If this is light. Okay, that's a wave. A wave is periodic disturbance in a medium. Right? That means you drop it, continue drop it, then the wave will keep on moving. Right? That's your ripple. That's your wave. Right? Progressive wave or traveling wave. Right? G is energy. Energy is transferred from one place to another by vibration. Right? The wave must start from somewhere. And you have a bottle in the sea there, you see the bottle move up and down. Why? Because the vibration or energy is transferred to the bottle. So the bottle is oscillating up and down. Right? So you look tiny enough, the molecules of water will also be vibrating up and down as the wave passes through, right? Or we call simple harmonic motion. As the wave passes through the medium, right? This is your medium. The particles of medium are in simple harmonic motion. Right? Each of the particle there, like example here, will go up and down. This part will be from here, going up and down also. Right? Same here. This part down will go up and down. Okay. So each of them will be in simple harmonic motion. Each particle is in different phase of motion. Different phase, I think at different position. If you give it an angle, it will be different angle. Okay. This will be at the maximum. Right? This part will be at rest position. No particle is permanently at rest. That means as the wave passes through, you won't see any particle at rest. Only at certain time it will be at rest, like here, at rest, at rest, at rest, not moving. Right? Sorry, at rest is that at the top there. That's at rest. Right? But for a while only, instantaneous. Right? Different phase, different position in the oscillation. Pulse. When a stone is dropped onto the water in a pond, the ripple travels outwards. Right? It doesn't carry on continuously. That's called pulse. Just instantly. Yeah, you drop a stone, but if you want the wave to continue, you have to keep on dropping a stone after stone after stone. So that is what the illustrate to your pulse. Just a short wave. Okay? Short wave. And then it move along. That's all. After that, no more already. That's how the wave move along. A ripple. Okay, so this is just the illustrate to you. This is a displacement. This is a distance x. This is your water. There's the surface of water. So as the wave passes through, right? There's the original position. You move to here. Next position. And So as the wave move through the medium, each particle oscillates at different phase. Okay, this particle at different phase. This particle, as we say, it can be at 90 degrees. Right? This particle at 0. This particle is at 180 degrees here. But as the wave move along, the particle here at the top there move downwards there. Right? At 90 degrees, move to 0. Or the particle here, 0, move to maximum. Or the particle here, move downwards there. Okay, so as the wave move further, basically the particle of the medium move up and down. That's all. Between two fixed points. There's your fixed point. The minimum and the maximum. And we call that motion simple harmonic motion. So if you look at the particle here, initially it's here, 0. Then you move upwards there. Then after that, it come down. Right? Or a particle here. Right? You take a particle here, minimum, it will move to here, 0, and then you move up to here. Right? So you keep on going. So each of them are at different phase. Right? This one is at minimum. This one is at 0. And other particle will at different angle. Right. So when we come to wave, there are terms that we have to memorize. Right? In your book, page 42, we can represent progressive wave with displacement distance graph. There's a displacement. That's a distance graph. Or displacement time graph. Right? So this is displacement distance graph. So what is displacement distance graph? Basically like taking a photograph of the wave as it moves along. Instant photograph of the traveling wave. Right? Side view. Show how the displacement of each particle varies with distance of the wave. Right? Now how the particle of the medium move from the distance from the wave. That's the crust, the maximum point. Trough is the minimum point. Right? Can fill up your worksheet if you are. Right? That will give you less time to work through. That's the reason for your worksheet. You can answer the question there, whatever is asked. If I'm too fast, tell me. Right? So that's basically undisturbed position of the water. The wave pass through. That's where the wave will go. Right? That's a wave motion moving to the right. Then you can draw an axis there. Right? The rest position is your distance axis. And you can start at any point you want to draw a vertical axis. Right? Displacement. And from crust to crust, or from trough to trough, or from same phase. Yeah? He's going down. That's called one wavelength. That's your crust, maximum point of the wave. Trough, minimum point of the wave. And this is the amplitude we call maximum displacement. Right? That's amplitude. We represent it with Y0 or A. Right? Previously, topic 19, we had represented X0. Right? But because we are going to use X for distance, we use Y0 for amplitude. Right? Not 10 for maximum lah, usually. Right? Or it can be here, amplitude. Right? This is displacement. It can be any value, depending on where you measure it. The largest one is the amplitude. Okay, let's continue with the term. Trough, that's your trough. Minimum point of the wave. Wavelength, that's your wavelength. Right? Distance between successive crusts or particles that are in phase. Right? It doesn't have to take the crust or the trough. You can take that one, that distance. That is going down. That one is also going down. Successive means one after another. So of course you cannot take from here to here. Right? These two are different. Right? This is going up. The next one going up is here. So that is your wavelength. Not from here to here. This one is going down, it's going up. That's what it means by successive, one after the other. Amplitude is the maximum displacement of the particle from its undisturbed position or rest position. That's the undisturbed position, zero position. Right? So that's the amplitude. Okay, in this diagram, is A the wavelength?
No, P is wavelength.
B is the wavelength. So A is less than the wavelength. Am I right?
Wait. No, P is the wavelength.
I know. A, is it greater than a wavelength or less than a wavelength?
No, the condition is it has to be between two successive crests or two.
I asked you different question, you answer me different question. I asked you a simple question. Is it greater than a wavelength? Less than a wavelength? That's all.
Greater than the.
Greater than wavelength. Right? That's your wavelength from here to here. How about P?
So,
how many wavelength is P?
This wavelength, two wavelength lah.
Two wavelength, you must be able to differentiate that. Right? So A is more than a wavelength, B is a wavelength, P is two wavelength. Right? If that is your time, that's your displacement, then in this case, that distance from crust to crust is called your period. Right? Equation of traveling wave, page 47. Right? We can represent it. Y equals to A sine phi. Right? If we call the angle phi, that angle. Right? Identify where is the position of this phi there, which angle. Okay, then we have to change this to angle. Right? And there's a formula how phi is related to x. Lambda wavelength equals to 2 pi. Now you can think of this as this is one wavelength, but this also in terms of angle, this is also 2 pi. Right? This is also 2 pi. So if you want to relate your phi, your angle, and your distance x, then this is the formula. Right? So in this case, lambda equal to 2 pi radian. X is proportional to phi. So we have that relationship. Phi over 2 pi is x over lambda. That's how we get this equation. Okay. So our phi is 2 pi lambda x. Right? So 2 pi lambda, we call it k. Wave number. Right? K is 2 pi over lambda. Right? Wave number. So we can rewrite the equation instead of in terms of angle, this part angle, we can write in terms of x. I call that x, distance x. Okay. Any comment? So we can replace this one with our kx. Right? Displacement diagram shows the displacement of particular particle with time as the wave pass through. Right? Here we are concentrating on one particle, how it changes with time, how it vibrates with time. That's all. It can be in different positions. It doesn't have to be all the same graph, but this is only for a particular particle. Right? Same, amplitude is the same. Y naught or A naught, maximum displacement of the rest position. That is the rest position. Frequency, right? From this displacement time graph, we have frequency. There is a Greek alphabet, no. That's your F. Frequency is the number of wave crust passing a given position each second. That means we can stand at that position, we count number of complete wavelength passing through or complete wave passing through, then the number per second is your frequency. I measure in hertz or per second. Same displacement. S is your displacement. That's your time graph. Period is the time between one wave cross and the next cross arriving at a point. Right? We can be the one observing it. Right? As the cross passes us, we start the stopwatch. As another cross comes along, we stop the stopwatch. That's the period. Measure in seconds. Right? Same thing. We can use the same period equal to 2 pi. Right? We can write this in terms of angle. Then this will be 0. This will be 2 pi. In terms of period, this will be 0. This will be the period t. So your time is proportional to your phi. So omega equals 2 pi f. Right? That's how your t period is related to 1 over f. Same formula. Just now we use x over lambda. So now we use t over capital T. Capital T is a period. And we can take the 2 pi across. So it's 2 pi t over t. And we call 2 pi over t is omega t. Right? That's the reason why we, instead of writing phi, we write a sine omega t. Okay. Let me just complete it with right? Same like here. Oh yeah, doesn't want to obey me. So we have quite similar equation. If we try that, right, where this one becomes your kx. That's all. Right? Either omega t or kx. This equation is kx. Okay, let's carry on. Right? We have come to here. Right? Remember, omega is the angular frequency. So you need to need to do your homework to force all these equations, these ideas into your head. These ideas, use this equation, then it becomes part of you. If you don't do it, you forget it. That's the reason why I say, after I teach you, go back another hour, spend reviewing it and do the exercise. That's the reason why I'm so good in maths when I was your age. Because after teacher teach, I do homework. Spend a lot of time in my maths. But physics, I couldn't understand. That's why I could not doing that well. Right? Didn't spend time doing it. Couldn't understand the textbook. Right? Phase, remember, phase of an oscillating particle, we can consider that as zero phase. And then this one is 90. When this one is coming here, it's 180. Right? Where it's going up is 0. Then this is 270. This pi is 360. Or this is 2 pi. Right? This can be time. This can be angle, as I say, or it can be time, or it can be distance. Right? So phase is identified to us where is the oscillating particle, whether it's at A or whether it's at 180 degrees or it's any part there, any angle. Right? If it's 270, we can see straight away. No need to calculate. Right? Our starting point is here. So usually identify as a phase angle. So here A is 90 degrees. Right? That's how we identify where is the position of A. And the phase difference between A and B is 180 degrees. No need to use formula. We can see from here, this is 90, this is 270. So we subtract 270 minus 90 is 180 degrees. Right? Or you should be able to say this is half a wavelength. Right? In terms of distance, is half a wavelength. In terms of time, you should be able to say this is half the period. Okay, are you with me?
Yes, teacher.
Okay. Right? So you should be able to flexible to identify straight away. No need to use formula sometimes. Right? So where we have two waves, two different waves, one wave P, one wave Q, then there's a phase difference. There's a phase difference. Phase describe the relative position of a crust or trough of two waves of the same frequency. These are two waves of the same frequency. Right? That's your phi. Phase difference. Sometimes we are interested which one comes first. Then we look at the time. That must be a time axis. Then we look at the time. Right? This one P comes first. Because it is 0 first. This one 0 later on. Or this one is maximum first. This one maximum later on. So we can compare the crust or the trough or any corresponding position. These two positions, this one and this one. Right? And then we can say P comes first, leads wave Q by a phase angle of phi. Okay, we can look at any distance, these two distance, or that two distance cross, and then there is the same angle, phi. Anywhere we look, corresponding point, right? Or we can do these two parts, same height, it should be phi. Right? What is monochromatic light? This is your STPM work. Can remember?
No.
Right? Light of a single color or light of single wavelength. What's the wave speed? Same. Right? Wave speed or wave velocity is the distance traveled by a wave per unit time. Right? You can identify a particular crust and see how the distance travel in a particular time. Then your distance divided by your time. Same. A uniform velocity, distance divided by time. And you have to remember this formula, V equals to F times lambda. How to derive it? Same, right? Since the time taken for the wave crust to travel a distance lambda is the period T, or T equals to 1 over F, the velocity of wave, right? We use our velocity, remember, no acceleration. This uniform velocity is just distance divided by time. Right? So if we travel a distance lambda, the time is one period, then lambda over T, capital T. So 1 over T is your frequency. That's how we derive frequency times lambda. Okay. And let's just review our sinusoidal. You need to know how to use it. Okay, so if you start with this one, you should know that there's the amplitude. Right? 500 is about here. If that is angle theta, that's your angle theta. But if you use time, then we have to replace the theta with omega t. Same here, you should be able to identify this as a cos graph. Right? Amplitude is 500. Time is in millisecond. Then omega t. Okay, you should be able to find the period from here also and find the value for omega. Right? Period is just here, 50. Right? At 0 to here, 50. Or you can take it from here to here, same thing. Okay, so if there is a motion or a shift, right, you should be able to identify. If there is sine x, that is your graph. If we add +1 to here, then we are just shifting there 0 to the left hand side. If there's a positive, that means it moves to the left. Right? Positive, the graph moves to the left. Okay, remember, we are shifting that C, not this one, that C. Right? That C is within that bracket. Right? So that is +1, it means it shifts to the left, -1. Okay, or we can shift this one to here, half pi. Then how do we write the equation? Same thing. Right? Let's see there. We shift half pi to the right. So half pi to the right is x minus half pi. Then use your trigonometry formula, you should get your minus cos x. That's what it is. minus cos x. When we shift the sign by half pi, it becomes minus cos x. Okay?
Wait, just 1 minute, sir.
Negative means motion to the right. Positive
Move to the right.
to the left.
Okay. Okay.
Okay?
Okay. Hey, but then why sine x minus the thing equals to negative cos x, sir?
Now go and memorize. I've done for you so many times already. Go and review from your note. Go and expand it. Sine A plus B. If you've forgotten, this thing you must remember.
Or the previous chapter one, you teach that
Yeah,
one,
chapter
sir.
19.
Okay.
For you already, I'm just repeating it to review with you. Right? You got your sine x, cos that. So cos 90 is 0. So you got a minus there. Minus cos x. That's why you got minus cos x. Sine half pi. Half pi is 90. That's why you get a negative sign there. This thing is supposed to be your math thing. You should be able to do mentally very fast. Right? So general wave equation, it has x and it got y. Moving in the positive x direction, we write as that. Right? Where there's a negative, is moving in a positive x direction. Is moving in a negative, moving in what am I doing? Sorry. Negative x direction. Okay, so you should be able to identify from the equation. This is moving in a, when it's positive, it's moving in a negative x direction. Alternative equation, we can have a cos graph, same thing. Negative means positive direction. Right? Positive means negative direction. That's all. It's a cos graph. Okay. If you have forgotten, this is a formula that I've gone over with you. You need to memorize that. Right? That formula, sine theta minus 180 becomes minus sine theta. Sine theta minus 90 equals to minus cos theta. Right? Just use this formula. This formula and this formula to get your equation. Right? Example of phase difference. Right? There's a phase difference of 45. 45 here. Right? It's in your worksheet. If you want, you can fill it up. If the amplitude of wave is V0, then the wave equation, right, for V1, this one, this is your V1, is a sine graph, omega t is your time. Then how to write the other one? So what is the other equation, V2? What's the answer for V2? Yeah, we move to the right at 45 degrees. How to write that? What's the equation? Can or not?
The equation, you asking about V2 or V1?
For V2, V1 is written for you already. Now I'm asking you for V2.
V2 equals to wait, in this case V1 starts at 0, this one starts at 45.
You have to convert your 45 degrees to radian.
So okay, V2 equals
Then write the
to
equation.
V naught sine bracket x minus 45 degree in radian lah. So yeah.
You know, simply use x must go and convert your 45 there. Right? Pi is 180 degrees. Just divide 180 or 360, and then this 2 pi, same thing. Then calculate it, it's quarter pi.
Yeah.
Write the equation. Right? V naught sine we are using t, so it should be omega t not x minus your pi. Pi in this case is pi over 2.
So
Pi
5 over 4.
3. Okay, we should be able to write the equation by just observing the graph. Okay.
Okay.
I can write it down in your worksheet.
Okay, so today no break, teacher just going on, right?
No, I will give you a break. I will give you a break. It's just a matter of we started late. I haven't covered enough, so no point in giving a break so fast.
Okay.
Okay, so phase, period, and displacement graph, or this should be wavelength. Right? The same thing. Right? This is a sinusoidal graph, same thing. Right? It's a sine graph. So you can read either, as I've said always, you can read in terms of period or time. Then this will be 0, this will be half a period, this will be a period. Or you can read in terms of wavelength, then this is 0, this is half a wavelength, this is your wavelength. Right? This is a quarter wavelength, that part there. Right? In terms of angle, then this is 0, this is 90, this is 180, this is 360. Right? You should be able to flexible convert in your mind. Right? Or read in terms of radian, which we'll be using rather than degree. Right? This is half pi, this is pi, this is 3 pi over 2, this is 2 pi. Right? 360 is 2 pi, this is 3 pi over 2, in the middle there, 270 degrees. Okay, or you can think of it in terms of a line, phase line, time, and then distance graph, they are proportional to each other. Right? This equation you need to know how to use. Okay, which I've earlier gone with you. Yeah, different way of viewing it, either sinusoidal graph or straight line graph, they are corresponding to each other. Okay, let us, this one is for you to do. Let us go to checkbook, checkpoint, rather than. Okay, let's try this question. In the figure shows a wave. Right? This is from your checkbook, checkpoint 20.1 in your book. In the figure shows a wave traveling along a stretched string. What is the amplitude and the wavelength? Okay, what is the amplitude? Yep, what's the amplitude? Yep. Finish. You will to tell me this is your STPM work revision only. What's the amplitude?
Amplitude is 10.
No.
5.
10 divided by 2 is 5. 5 cm. What's the wavelength?
The wavelength is 30 divided to 15.
Read properly lah. Don't simply read. Read carefully.
Yeah lah, there's 30 cm there lah. Say you only want one wavelength.
Where got two wavelength? Where got two wavelength? Read carefully.
Oh, there's 2.5. So 30 divided
that's why I say read
2.5.
carefully. Don't so carelessly read so fast. Read carefully.
30 divided 2.5.
2.5 wavelength equals 30. And find your wavelength. Okay, what's the phase difference between point W and X? That's your W. That's your X. Right? Write this in terms of angle. Then you can see what's the phase difference. Right? W and X. Yep. This is 0. Then what should this be? If this is 0 angle, what should this be? This is your mass. What is the angle for here, for x?
0.
If this W is 0, x is how? What is the angle?
Wait. 90.
Huh?
90.
There got 90. Right? W to T is 360. So half is 180 here. Right? You better go and review your maths. Cannot afford to read wrongly. This is your maths work. This 0, this 90, this 180, this 270, this 360. Must know that. Right? That's the reason for reviewing with you just now. Right? That's how I review with you there. 90. Know how to identify, read all this. This 90 or half pi. This 180 or pi radian. Right? This is 270 or 3 pi over 2. Right? This is 360 or 2 pi. Right? Make sure you know all that. Then you can do it very fast. Okay, what's the other answer for the other one? So what's the phase difference between W and X? Yeah, W and X, what's the phase difference? We just review it. Why it takes so long?
Which one? B2, Acha?
Yeah, B1. You haven't given me the answer.
B1 is 180.
Or pi radian. How about number 2? W and Y.
360. 360.
You can either use a formula to calculate, but it's easier if you can read faster. Right? Usually we prefer to use radian. How about X and Z? Yeah, X and Z.
270.
Then the other one? W and Z.
W and Z. 450 over 360. Yeah.
What? What's the answer?
Okay, 450 degrees lah. Sure.
450 degrees. Right? Learn to
Yes.
convert it to radian. Don't work with degree.
2.5 pi lah, basically. Sure.
Yeah, 2.5 pi. Okay. If the speed is that, what is the frequency?
V equals to F lambda.
Calculate out. What's the answer? That's the reason of
So
walking through
0.48. So 0.48.
So you understand the lecture.
0.48 divide. Teacher, take out that black thing, teacher. It's blocking the question.
You should have your own textbook. What are you doing?
Sorry.
Your textbook should be with you. Your reference book should be with you. Not concentrating on my slide. I think you are not bringing your book along. You are very
so 0.48 divide 12.
Right? Speed divided by wavelength.
0.48 divided by 12.
So it's 4 hertz. Okay, what is the difference between longitudinal and transverse wave? Yeah.
Longitudinal, they are perpendicular. Transverse, they are
right? Longitudinal, right? All this must be in your head. The particles vibrate in the direction of travel of the wave. Transverse wave, the particle of the medium vibrate perpendicular direction of wave. Give an example of each. Example of longitudinal.
example of longitudinal. Sound wave.
Transverse. Yeah, why so long one? Not paying attention in class, we just teach you. Electromagnetic waves, that's your SPM work. Okay, that's your homework. So we give you all 5 minutes, then we carry on with intensity.
Okay.
Anything you want to ask before I stop?
Nope.
Okay, if not, take 5 minutes break, then we spend a short time for intensity.